Again, welcome back to C++. This lectures cover the C++ selection statement. So we start with the relational operators. Normally, relational operators are used to construct the expression, conditional expression. And the condition, there's only two possible answers, either true or false. So the operators are greater than, less than, greater than, equal, less than or equal, equal, and not equal. Example given here, 12 greater than 5 is true. 7 less than or equal to 5 is false. So always our condition will be only two outcomes, either true or false. We also can assign, for example, we have a variable named x. We assign 10 to x. So we can also use the variable because we know the variable content is 10. So here we say is 10 equal to 10? That's true. Is 10 not equal to 8? That's true. Is 10 equal to 8? That's false. Also, we can also assign the result to a variable. So for example, here we say is x less than or equal to y. If it's true, then we assign 1 to result. If it's false condition, we assign 0 to result. So let's start with the if statement first. So in C++, the if statement allows us to test a condition. If the condition is true, we execute the statement that follow. If the condition is false, we skip it. So for example, here we say, is it cold outside? Yes. Then we execute our statement where a coat. Is it cold outside? No. Then we skip again the statement. And we can have as many statements as we want. So again, is it cold outside? Yes. Then wear a coat, wear a hat, wear gloves. If it's no, skip everything. So the general format is if expression. Again, this expression must be a conditional using relational operators. If the expression is true, then we execute the statement. If it's false, then we skip it. So again, if the expression is true, then statement is executed. If expression is false, then statement is skipped. So let's see one example here. This program averaged 3 test scores. So again, we include our IO stream, IO manip for then using namespace std. So we declare variable name high score. It's a constant variable. We assign 95 to it. As we said in previous lectures, anytime you declare variable as constant, we need to initialize it. Then we create a 3-score variable, score 1, score 2, score 3. Then we have a variable named average to hold the average score. So we ask the user to enter the 3 scores. So enter 3 test scores and I'll average them. So we have seen score 1, score 2, score 3. As we said in the previous lectures, if I want to enter 80 and 90, I will enter 80 first, then I'll press the space bar or enter key, then I enter 90. So anytime we enter values between, use the enter key. So we have the 3 scores now, score 1, score 2, score 3. We find the average, which means we had all the 3 scores and we divide by 3. We assign the result to average variable. Then here we just format the output. We set the precision to only 1. That is decimal places to only 1. And we say, okay, your average is whatever result we have. Now, this is what we are learning. If the average is greater than high score, then we are going to say, congratulations, student did good. That means if the student average score is over 95, then we print the statement. Now, if the score is less than 95, then we are going to skip the statement. And then why we say 95? Because when the variable is declared high score, it's a constant variable, we initialize it to 95. So anytime we use the variable high score, it means the content 95. So here we enter 3 scores, 80, 90, 70. The average is 80. And you can see that the congratulation was not print. We skip. By the second input, we have 100, 100, 100. So the average is 100. Since 100 is greater than 95, we say congratulations, that's a high score. So that's the flow chart for the program again, line 22 to 23, where we test our score. So we're testing if the average score we have is greater than 95, which is the variable I score. If it's true, then we display congratulations, that's a high score. If it's false, we skip it, the statement. So there are some few notes here, especially the syntax. So do not place semicolon after the expression. So if we enter the condition, if score greater than 90, we don't end it with semicolon. Also be careful when we are testing a float, that's a decimal value. Preferable is always better to test a whole number because whole number go 1, 2, 3. Decimal number, we don't know how many decimal places. Sometimes we need to approximate it also. So here also we can have more than, anytime we have more than one statement, we should put it in a curly brace, open and close curly brace. So here we say to execute more than one statement as part of an if statement, we should enclose them in a curly brace. Now, if we do not, then only the grade equal A will be the only thing that will be affecting the condition. So this means if the condition is true, grade A will be assigned to the variable grade, and we print good job. If the condition is false, we're still going to print good job. That's if there's no curly brace. So in order, we can have as many statements as we want. As far as all the statements are in the open and close curly brace, the condition will affect all of them. We call this the block of the code. So the next one will be the if-else statement. The if-else statement now provides two possible paths of execution now. So if only the condition is true, we execute. If it's false, we skip. Now with if-else, they give us an option for the else section. So if the expression is true, we execute statement 1. If the expression is false, we execute statement 2. So this is if-else. So we say again, if the expression is true, then statement 1 is executed. Statement 2 is skip. If the expression is false, then statement 1 is skip and statement 2 is executed. So let's see an example here. Here again, this program uses the modulus operator to determine if a number is a odd or even. So if the number is evenly divisible by 2, then it is an even number. A remainder indicates that it's an odd number, because if you divide any number by 2 and you have a remainder value at least 1, you have remainder, then that means again it's a odd number. So here we declare variable name number. We tell the user to enter an integer and then tell if it is odd or even. So seeing we enter the number, we test the number if it's even. So we modulus 2. Again, dividing a value by 2, the remainder will give you 0. That means it's even number. If the remainder is not 0, it means it's odd number. So we test it. If non-modulus 2 equal to 0, then see out, the number is even number. Else the number is odd number. If it's not, the remainder is not 0. So that's what we are learning here. We are using if-else. If the condition is true, number is even, will execute. If the condition is false, number is odd, will execute. So for example, here we enter an integer, 17. 17 is odd because 17 modulus 2, the remainder is 1. So the odd section, false section, execute. So that's the flow chart. Number modulus 2 equal to 0. If it's false, indicate that the number is odd. If it's true, indicate that the number is even number. Also, this program asks the user for two numbers, num1 and num2. Then num1 is divided by num2 and the result is displayed. Before the division operation, however, num2 is tested for the value of 0. If it contains 0, the division does not take place. Because anytime we divide the value by 0, we get an error. So here again, we declare variable num1, num2, and quotient. We ask the user to enter the first num1 and also ask the user to enter the second value, num2. Then we say, okay, if num2 is equal to 0, then division by 0 is not possible. Please run the program again and enter a number other than 0. So this is what we'll be printing out. Else, if the condition is false, that means we can do the division. So quotient equal to num1 divided by num2. And we say that the quotient of num1 divided by num2 is the answer quotient and variable. Also, we can have what we call the nested if statement. So an if statement that is nested inside another if statement. So nested if statement can be used to test more than one condition. And we will see example on the flowchart here. So in the flowchart here, we say employ yes or Y. If it's false, display you must be employed to qualify, which means you are not employed. If it's yes, it's true, or Y is true, then we check if it's recent graduate. So now we are going, this will be nested if statement inside under if statement. If this condition is false, then we display on the left side. If it's true, we display on the right side. So let's see how the code looks like. So here we say if employee equal to Y, if it's true, then we check if it's recent graduate. If it's true, then we print out you qualify for the special interest rate. Now, if it's false, then we come out. So this is again, if employee equal to Y, if recent grad also is Y, which is nested if, you qualify for special interest rate. Else, now if this condition is first of all, if the outside condition is true, if employee equal to Y is true, then we can go and test the second condition. If the condition is false, we can't go inside no more. So first condition is true, we check the nested if statement. If it's true, then we print the output here. If it's false, then we print else. You must have graduated from college in the past 2 years. But again, if it's false, then we come to the last else here. You must be employed to qualify. So we can see that the outside if goes with the outside else. Then the inside if goes with the inside else also. So that's what we call use the proper indentation. We can see if employed equal to Y goes with else outside. The inner one, inner if go with the inner else. So test a series of conditions until one is found to be true. Often simpler than using the nested if statement. Can be used to model thought process such as if it is raining, then an umbrella, else if it's windy, take a hat, else take a sunglasses. So what we mean is that anytime we have more than two states, now if we have two options, we can use if else. Now if we have more than two options, then we can use what we call the if else if. So for example, if expression is statement one is true, statement one was an else, we have expression two, and this can keep going to the end. We can have any amount of, and let's say here we say n expressions. But in order to use this, we need to have at least 3 or more. So this is a nice example here. We want to determine a letter grade. The letter grade can be A, B, C, D. So at least it's more than 2. So here we are using if, else, if, else, if. Always the last option will be else, which means that if all the conditions are false, the last condition will execute. So for example, here we say if test score is greater than or equal to A score, then we're going to print your grade is A. Else, if your score is greater than or equal to B score, then your score is B. Else, if the test score is greater than or equal to C score, we print your score is C. Else, if your test score is greater than or equal to D score, then your grade is D. So the first four, A, B, C, D, we have conditions to test. If all the conditions are false, then the last option will be C out. It means your grade is F. You fail. Now, here we say the trailing else clause is optional, but it is the best to use to catch errors. I would say it's very good always to use it because in this case, if all the conditions are false, the last option will execute. So if-else initialization, this is another feature that is introduced in C++17. Here we say if statement can have an optional initialization clause that is executed before the condition expression is executed. So you can see if we're going to have initialization here, some variable niche, then expression will be checked. If it's true, then we execute the statement. So let's see an example here. If initialization expression, else another statement. So we can use it as only if, we can use it as if else. So that's a good example here. Here we declare variable name len, and we initialize it to the password length. So if the password length is 10 characters, then it means we initialize the variable len to 10. Now, when we initialize it to 10 finish, then we check if length is less than the minimal length. So is it 10 less than the minimal length? If it's true, then we execute your password is too short. But if it's false, then we say your password has whatever length it was. So this is an option. I want to check a condition. Length is less than or equal to min length. I can declare inside the condition statement or the parentheses, open and close, we can declare the variable and initialize it at the same time and use it to test a condition. So that will be the conclusion of this lecture. So in this lecture, again, we covered the basic C++ conditional expressions such as if else, nested if, and multiple if else statements. So in our next lectures, we're going to cover the switch statement. Thank you.